So the parent function is what we're going to use to apply the transformations that we're going to be doing in this section. Then we'll notice below our parent functions, we have a table that tells us about the different translations, reflections, and stretches. We also have, given the basic graph or the parent graph y equals f of x, we're going to assume that in this table, b is a positive number, the absolute value of c is bigger than 1, and the absolute value of d is less than 1. We're going to need these conditions to help us pick the proper row in that table as we are doing our problems. So let's go ahead and take a look at example number 1. So example 1 says, describe how the graph of g of x, which is equal to 1/2 times x minus 3 squared plus 4. So this is going to be our parent function. So we want to figure out how g can be obtained from the graph of f. And that's where our table is going to come in handy. So we look at our parent function and we want to see what's happening. So I have a multiplication. So here's my squaring. So that's going to be my parent. So my square is this. So instead of just x, I have x minus 3, and then I have a 1/2, and then I have a plus 4. So we want to look at each of these, which I'm going to color code. So let's go with we'll do the 1/2 in green, we'll do the x minus 3 in blue, and the plus 4 in red. So this is 1/2 times something. So we go and we look at our table here, and when we have our function, we have it multiplied by something. So that means we're either in this row or this row. So we have c times something or d times something. And we look at what our number is. So our number is 1/2. So when we look at our table, the way we determine whether it's c or d is up here. So is 1/2 bigger than 1 in absolute value, or is 1/2 less than 1 in absolute value? And it's less than, so that means we are going to pick row D from our table here, and that's going to tell us the first thing that happens. So our D is the 1/2, and so this tells us that our graph shrinks by a factor of 1/2. And then we don't need the second part, but if this number, the 1/2, would have been less than 0, it would have caused a reflection across the x-axis. But for us, it just shrinks by a factor of 1/2. So now, the next thing we do is we look at the x minus 3, which is what we have in blue. Well, that is inside of our squaring function, so composition, and we come and we look, and we need it to be inside, and so we have x minus 3. So then when we look at our table here, we have the minus, and it's on the inside. So that means we are going to take the f of x minus b entry from our table. So then that gives us our x minus 3. So that makes our b is 3. So the graph is going to shift 3 units to the right. And now we have our last part, which is the plus 4. So now we're adding something on the outside. So that's going to be actually the very first row in our table. So this part right here. And we have our plus 4. So that's going to be our b. So b is 4. And then our conclusion is then it's going to shift the graph up 4 units. And that is what we are going to get for our translations for each of these. So when we have our parent function, we identify it, and then we need to figure out, well, what's happening to that parent function and match them up with the appropriate rows from that table. And it will tell us what is happening to our graph. For this U-try, we identify our parent function as the absolute value of x, and we want to describe how the graph of 3 times the absolute value of x plus 5 minus 1 can be obtained from the graph of the original function. So once again, we have our 3 out in front. We have our x plus 5 here, and then we have...
Professor, you're muted.
Oh, okay. All right, so to work this example, the first thing we need to do is identify our parts. So we have our 3 here, and then we're going to have our x plus 5, and then we're going to have our minus 1. So we take a look at our sheet, and we determine whether or not we have c times f of x or d times f of x by looking at our c or our d. So our number is 3, so the absolute value of 3 is bigger than 1, so we're going to have the c row from our table, which gives us this. So then what we're going to have is our c is 3, so it's going to stretch by a factor of 3. Once again, it's positive, so the graph does not reflect. That only happens if it's negative. And then we have our x plus 5. So we have x plus 5, and that's going to be here because it's on the inside. And we identify our b value in this case. So our plus 5 gives us b is 5, so we're going to shift left 5 units. And then our last part is we have our minus 1, so that's on the outside, so that's going to be row number 2 in our table. And so we identify, we have our minus 1, so we have minus b and minus 1, so that tells us that our b is 1, so we're going to shift down 1 unit. So notice on that one it does have a minus sign in the formula, and that gives us our 3 things. So we're going to stretch by a factor of 3, we're going to shift to the left 5 units, and we're going to shift down 1 unit. And that'll give us what our graph is going to look like.
Professor, does the 1 become a right?
Let's go ahead and take a look at our next example. So example 2. we have our parent function this time is 1 over x, and our g of x is 1 over 10x plus 5. So we want to determine how this is going to be. So this problem actually can be done in 2 different ways, and we'll see that we get the same thing. So I'm going to write it out both ways. So if our f of x is 1 over x, we can identify g of x as f of 10x plus 5, because if I replace the x in 1 over x with 10x, what would that give me? Well, if I replace x with 10x, I would get exactly this. So one way to visualize this is as function composition. But we'll notice I could also visualize this as g of x would be equal to 1 over 10 times f of x plus 5. Because if I have 1/10 times f of x, well, f of x is 1 over x. If I do that, I also get the same thing, which is 1 over 10x. So I can visualize this in 2 different ways, either as a composition or as a multiplication. And that's fine, because as we'll see, math doesn't care which way you look at it. We will get the same correct answer either way. The only reason I mention this is if you're working with someone, they may visualize the problem in a different way, but as long as we identify the right rows in the table, we're going to get the same correct answer in the end. So this is one of the reasons why you keep hearing me say that I am goal-oriented and not path-oriented, because there's more than one correct way to get from A to B. So let's start with the one that we have on the left over here. If I have my 10 inside my function f, that takes me down here to the last 2 rows in my table. And once again, I need to decide, is it a C or a D? So is 10 bigger than 1 in absolute value, or is 10 less than 1 in absolute value? Well, 10 is bigger than 1, so that's going to make it a C. I'm going to have to do this a little differently. Since we don't need the second part, we'll just do this part. So then this tells us if we identify our C in this case is going to be 10. So what does this do to our graph? It shrinks by a factor of 1 over C, so that's going to be 1 over 10, right? Well, now let's jump over to this one. On the outside, I am multiplying by 1/10. So that's on the outside, and then this time we look at C and D. Is 1/10 bigger than 1 in absolute value, or is 1/10 smaller than 1 in absolute value? Well, it's smaller, so in this case it's going to be a D. And if I look at the D in this one, we identify our D as 1/10. So then what does this tell me happens? Well, it shrinks by a factor of 1/10. So notice, either way I visualize that problem, I end up with the same conclusion, that it shrinks by a factor of 1/10, right? whether I recognize it as a composition or I recognize it as multiply on the outside. Both are correct. So this is not uncommon in this type of problem that there's going to be more than one correct way to visualize it, and that's fine. You'll get the same correct answer in the end. Then in both cases this time, we're adding 5 on the outside. So we go back and we look at our table, and if we're adding 5 on the outside, that is our first row in our table, and it's the same for both of them. So then that's going to identify B as positive 5. So that's our B. So our graph shifts up 5 units. So, and that one is the same in both. So just be aware that this can happen both ways, and that's fine. And we're going to get the same answer either way we do it. All right, so example number 3, we're going to be doing the same thing, but this time instead of being given a function, we're actually given a graph, and we're asked to produce the graph of g of x, where g of x is negative 2 times f of x plus 3. So we have our negative 2 out in front, and we have a positive 3. So if we look at our chart, once again, if I have a negative 2 out in front, so the absolute value of negative 2 is positive 2, and positive 2 is bigger than 1, so it's going to be a C on the outside, but our C value is negative 2. So then what's going to happen to our graph is the following. So we have our C value is going to be negative 2. So then our graph stretches by a factor of the absolute value of C, so it's going to stretch by a factor of 2. And since C is less than 0, the graph is reflected across the x-axis. So that's our first part. So it's going to take our graph and it's going to reflect it across the x-axis. So if we're at negative 2, this thing is going to reflect up here, and this one is going to reflect down here. So our graph looks kind of like this. So that's our reflection. But then what else do we need to do? Stretch it by a factor of 2. So instead of being at 2, it's going to stretch it to a factor of 4. And here, instead of being at negative 3, it's going to stretch it to a factor of negative 6. So that was 1. This is 2. And then lastly, we have a plus 3. What is that going to do to our graph? Well, the plus 3 is our first row in our table. So that's going to take our graph and it's going to shift it up 3 units. So we identify our B as 3. So we're going to shift up 3 units. So we're going to take all of our points and move them up 1, 2, 3. Take this point up 1, 2, 3. And this point goes up 1, 2, 3 to here. And that gives us our final graph. So that last one in red represents what our graph g of x would look like. And we obtain that by reflecting our graph across the x-axis, stretching it by a factor of 2, and then we shifted the entire picture up 3 units. So this is just us acting out what we were identifying in the previous problems. All right, so we need to identify what we had to do to f in this one to get g of x. So we notice that we have x and then 1 over x, and we have then 1 over x plus 5. So it looks like to get g of x, we replaced x with x plus 5. So f of x plus 5 is going to be 1 over x plus 5. So we look at our table, and that gives us row 3. So we identify our b as positive 5. Identify our b as 5. And we're going to shift left 5 units. All right, so then for you try number 3, we need to do the same thing and then shift our picture that was given the appropriate way. So we look at our g in this, and we have our two things. We have our x minus 6 on the inside and our plus 7 on the outside. So our x minus 6 on the inside is going to shift. This time it's negative 6, so this time it is going to go right 6 units. And then the plus 7 on the outside is going to shift up 7 units. So we're going to go right 6 and up 7. So if I take this point and I go right 6, so 1, 2, 3, 4, 5, 6, and then up 7, 1, 2, 3, 4, 5, 6, 7. And I do the same thing here. I go right 6, 1, 2, 3, 4, 5, 6, and up 7, 1, 2, 3, 4, 5, 6, 7. My graph is going to look like this. Even though it went off the edge, it would look something like this. So we took our picture, and imagine you just grab it and you move it right 6 and up 7 and then set it back down. And that's what our solution is going to be.